10-2 quadratic functions A. The video needed to be cut into two parts. Sorry. Objectives: to graph quadratic functions of the form y equals ax squared plus bx plus c, and to graph quadratic inequalities. The graph of a function, the graph of a quadratic function. The graph of y equals ax squared plus bx plus c, where a does not equal 0, has the line x equals negative b over 2a as its axis of symmetry. We'll go over that in the lesson ahead. And then the x-coordinate of the vertex is negative b over 2a. And let's go to example 1. I don't know why it did that. Example 1. Graph each function. Label the axis of symmetry and the vertex. So, there are a few steps to this, and so step 1. We are going to find the axis of symmetry. Axis of symmetry. Remember, the formula is negative b over 2a. So you're going to plug in, a is the number in front of x squared, b is the number in front of x with a negative attached with it, and c is the number after the x. So axis of symmetry, we'll do negative and then negative 6 over 2 times 1. And so negative and a negative make a positive over 2, and that equals 3. So x equals 3. We found the axis of symmetry, so we are going to graph that. So we're going to go down to the graph and find 3 on the x line. So that's right there, and we're going to put a dotted line straight up and down. That's our axis of symmetry. Step 2. Find the vertex. So you're going to take the equation they gave you at the beginning, and you're going to plug in 3 for the x's. So it's going to be 3 squared minus 6 times 3 plus 9. So we just substituted 3 in for the x, and this will be our y. And so that would be 9 minus 18 plus 9. Did the math, and that equals 0, and that's y. So our vertex is going to be the 3 from the step 1 and the answer from step 2, so 3, 0. And you're going to graph that too, and you're going to find 3, 0 on your graph. Now step 3. Step 3, you're going to make a table like we did before, except all you have to do is only 2 numbers. I'm going to put x here, and I'm going to use 0 and 1. If you have a 1 or a negative 1, you're going to use, for your vertex, you're going to use the opposite of that number. So we want to have 0. That's nothing, but we also want a 1 or a negative 1 on there. And so I'm going to do the math. I don't know if I have the space for it. So let's see, we have x squared minus 6x plus 9. So that would be 0 squared minus 6 times 0 plus 9. So that would be 0, 9. And then I have 1 squared minus 6 times 1 plus 9. And that would be 3. So it would be 1, 3. So I'm going to graph those 2 points. I'm going to have 0, 9. Some of them are going to go off the graph. 0, 9. And 1, 3. And you're going to graph half of your parabola. So step 4 is graphing. Graph the other half. All right. So as you can tell that there are 2 spaces on the left-hand side, so you're going to find 2 spaces on the opposite side. And then you erase it. And for the top one, you have 3 spaces. You're going to do the same thing on this one, so 3 spaces. And then you make your parabola. And here is your answer for step 1. For example 1. Why don't you try example B on your own and put me on pause, and then you'll see if your answer is correct. Okay, here's step 1 through step 4. If you need to look it over, put it on pause, check and see if you got the answers correct, see what you did wrong, and we're going to go off to example 2. Example 2. They give you this formula for, it describes the height above the ground of an object falling from an initial height. So the formula that we're looking at, that we're going to be using for a couple lessons, is h equals negative 16t squared plus vt plus c. The t means time, the h means height, the v means velocity, and c means the initial height of where it started from. So, A. In professional fireworks displays, aerial fireworks carry stars upward, ignite them, and project them into the air. Suppose a particular star is projected from an aerial firework at starting height of 520 feet with an initial upward velocity of 72 feet per second. How long will it take for the star to reach its maximum height? So we're going to find out how long it takes first. So using the formula that we've been practicing, which would be negative b over 2a, that also will work to find our time. Usually it's x, but t took the place of x. Oh, and that's supposed to be t squared right there, because the equation negative 16t squared plus 72t plus 520 will be what we're going to use for our formula. So we're going to have negative 72 over 2 times negative 16. So negative 72 over negative 32, which is 72 divided by 32. 225. That's our time. That's how long it took. So that's our t. That's one answer. And then it says how far above the ground will it be? So that's our h. So again, for h, we're going to plug them into our t on the formula that's given. So it's going to be h equals negative 16 2.25 squared plus 72 2.25 plus 520. And your calculator amazingly does all the work for you in order of operations, so all you have to do is plug it in exactly how it is here. So you're going to go negative 16 times 2.25 squared plus 7 times 2.25 plus 520. And Miss Carson did something wrong here because I know the answer is not what I had. That is 72, not 7, 72. And that equals 601 feet. So in 2.25 seconds, it gets up to 601 feet. And then we have on B, a ball is thrown into the air with an initial upward velocity of 48 feet per second. Its height in h after in feet after t seconds is given in the function. So they give you the formula. Again, in how many seconds will the ball reach its maximum height? And what is the ball's maximum height? So I'd like you to do that and put me on pause, try it yourself, and then when you're finished, put me on play and check and see if you got it correct. All right, so you have 1.5 seconds. It reaches 40 feet. That's the maximum height. This is video 1, so watch video 2.